Students, here we are going to start the topic about dielectrics, and we know about the insulator and conductors. Now what we want to know about the dielectrics. What do you know about the dielectrics? It is a very important topic and very interesting topics is there. We know that in an atom or molecule, electron is either free or bound to the atom. Free in the maximum in the case of what we can say it is in the case of conductors. But when you take an insulator, you will find that these electrons are bound to the atoms or molecules. Is it clear? The electrons are bound to the atoms or molecules. Now, it is found that in some cases, whenever some electric field is given to some type of to the insulator, whenever some external field applied to some insulators, it is found that these electrons will suffer a small movement within the atoms or molecules. Is it clear? When you give some external field, it is found that these electrons will suffer a small movement inside the atoms or molecules. And due to these movements of electrons in the atom or molecule, they will create some electric field, or we can say that they will get the important properties of electric field. On the basis of these electric properties, insulators are called dielectrics. Is it clear? On the basis of these electric properties, insulators are called dielectrics. Again, I am repeating. We know that whenever there is a conductor is there, in conductor there is a free electron is there. And this free electron, when you apply electric field, it can move on the surfaces of the conductor. Is it clear? But in the case of insulator, the electrons are bound to the atoms or molecules. Is it clear? Now, as they are bound to the atoms or molecules, still, if we have applied some external field, it is found that these electrons inside the atom or molecule, they will move inside the atom. There is a small movement is there. And for that movement, we will get the properties of electricity or electric field. Is it clear? And such materials which shows the properties of electric field or electricity, whenever some materials means what? Such insulator which shows the properties of electric field, whenever some external field is applied, is known as, what is known as? It is known as dielectric. Is it clear? Again I am repeating. Dielectrics are the insulating materials. Dielectrics are the insulating materials which transmit electric effect without actually conducting electricity. Means what? It will not conduct electricity, but it will acquire the properties of what? Electricity, or it will conduct, what we can say, it will transmit the electric effect whenever some external field is applied. Again I am repeating, dielectrics are those insulating materials which transmit electrical property or electrical effect without actual movement of the electrons. The electrons are moving among themselves. It is not moving on the free surface, on the surface of the conductor. But what is the insulator? What is there? They are creating electric effect whenever some what? External electric field is given. That is the main theme of what? That is the main theme of this dielectric. Again I am repeating, be serious about this topic. What is the dielectric? Dielectric are the insulators. Generally dielectrics are not the conductor. You should not differentiate it. It is not the conductor, it is an insulator. Where if we apply some electric field, then without movement of electrons, it will create or it will transmit electric properties. That is the dielectric. Is it clear? Clear now? I think it is clear. Now we are going to discuss about the types of dielectrics. What we are going to discuss? About the type of dielectrics. Generally, the dielectrics can be divided into two categories. One is known as polar dielectrics, second one is known as non-polar dielectrics. Is it clear? One is known as polar dielectrics, other one is known as non-polar dielectric. What is polar dielectric? Polar dielectrics are those dielectrics whose center of positive charge and center of negative charge never coincide with each other. Is it clear? We know that if an atom is there, in the atom there is an electron is there, and there is also proton is there. That means that positive charges are there. They both have the centers, and if the centers do not coincide with each other, then we can say it is a polar dielectric. If they will coincide, then they will known as non-polar dielectric. Again I am repeating, if the centers of positive charges do not coincide with the center of negative charges, they said to be polar molecules. And these polar molecules are asymmetric in shape. These polar molecules are asymmetric in shape, like your hydrogen, like your water molecule, like your HCl molecule. So they have a permanent dipole moment which is of the order of 10 to the power minus 30 coulomb meter. Is it clear? They have a permanent electric dipole moment that is of the order of 10 to the power minus 30 coulomb meter. Now, what will happen? What are the examples? Examples: water molecule and HCl, NH3, CO, CH2OH, etc. are the what? Are the examples of polar molecule. And water molecule has a dipole moment of 6.1 into 10 to the power minus 10 coulomb meter. Clear? Sorry, 10 to the power minus 30 coulomb meter. Water molecule has a dipole moment of 6.1 into 10 to the power minus 30 coulomb meter. So this is about your polar molecule. Again I am repeating, polar molecules are those molecules whose positive charges, whose center of positive charges and center of negative charges never coincide. They are asymmetric in shape. They are asymmetric in shape, shape. Is it clear? And for that reason, they have a permanent dipole moment having the order of 10 to the power minus 30 coulomb meter. Is it clear? And the examples of polar molecules are HCl, NH3, water molecule, CO, CH3COH. These are the CH3OH. These are known as polar molecules. and the dielectric, which are made up of polar molecules, are known as polar dielectric. Is it clear? Water has a dipole moment of 6.1 into 10 to the power minus 30 coulomb meter. This is about your polar molecule. Clear or not? Polar molecule we have cleared now? Now let's come to the discuss about the non-polar molecule. What do you know about the non-polar molecule? Just I told you that if the center of positive charges and center of negative charges do not coincide, they are known as polar molecules. And if in the molecules, if the center of positive charges coincides with the center of negative charges, they are known as what? Non-polar molecule. And the dielectrics, which are made up of non-polar molecules, are known as non-polar dielectrics. They are symmetric in shape, not asymmetric. They are symmetric in shape, so their dipole moment is zero. Is it clear? And some examples of non-polar molecules are H2, N2, CO2, O2, CH4, etc. Is it clear? H2, N2, CO2, CH4, O2, etc. are the examples of non-polar molecules. Is it clear? This is about your what? Polar molecule and non-polar molecule. Clear or not? I think it is clear. Is it clear? Now we are going to discuss about how the electric field affects polar dielectric. Is it clear? Effect of electric field on polar dielectrics. What we know? We know that polar molecule have a permanent dipole moment. Is it clear? Polar molecule have a permanent dipole moment. It means their negative charges and positive charges, they have a permanent electric field. But as you know, if some molecules are very closer to each other, then what will happen? There is an effect of heat is there. Is it clear? Due to this thermal agitation, they are arranged in such a way that the net dipole moment is zero. Is it clear? We know that we know that polar molecule have permanent dipole moment, but they are arranged in such a way, these polar molecules not in a single number. When you go to polar molecules, you say a large number of molecules are there, and due to the large number of molecules, they are arranged in such a way due to thermal agitation, that means due to the heat, the net dipole moment is considered to be zero. Is it clear? Net dipole moment is zero. So here what will happen if we apply electric field, then these polar molecule will arrange in the direction of applied electric field in such a way that they will get a net dipole moment. My point is clear. Whenever a polar molecule is taken, initially in their single atom they have a dipole moment, but as in together, when we take a large amount of molecules, when you take your molecules of polar molecules will take, then we can say that net dipole moment is zero. Why net dipole moment is zero? Because the dipoles are arranged in such a way that the net dipole moment cannot polar molecules are arranged in such a way that net dipole moment becomes zero. Is it clear? Now when you apply electric field, what will happen? They will arrange themselves in such a way, they will have a permanent dipole moment. They will get a dipole moment, effective dipole moment. Is it clear? So this is about your polar molecules, how it is affected by electric field. Now let's take the example, let's take what will happen if we take non-polar molecule. If a non-polar molecule is there, we know that the center of the positive charges and center of the negative charges are what? Are at the same point. Is it clear? They are coinciding. So what does it mean? That dipole, that means for dipole moment of each non-polar molecule is zero. Dipole moment of each polar molecule they will not be zero, but non-polar molecule have a dipole moment is zero. Is it clear? Now what will happen if we give an electric field? Then this non-polar become polar. Means what? Their centers will change and now they will have a permanent dipole moment. Is it clear? They will get a permanent dipole moment. So both are getting permanent dipole moment after the application of electric field. But in the case of polar molecules, what we get? We will view that in the polar molecule. Initially they have a dipole moment among themselves. Okay. And initially their net dipole moment is zero only because their arrangement, due to the arrangement. Is it clear? But in non-polar molecule, their centers are coinciding with each other. Center of positive charge and center of negative charges are coincides with each other. So net dipole moment in case of non-polar molecule initially when no electric field is applied is zero. Now when you apply electric field, what will happen? The centers will change, then they will attain a permanent dipole moment. Is it clear? So this is about how the electric field will affect to polar and non-polar molecule. Clear? Now we come to discuss about the polarization of dielectrics. How the dielectrics can be polarized. For that reason, we have taken the positive plate and negative plate of a capacitor and connected it with the external electric field. Is it clear? So, the electric field, when no dielectric in between them, it is E0. Suppose sigma is the charge density. Here sigma, here it is minus sigma. Is it clear? It is minus sigma. Minus sigma is the charge density here. So we can say that the value of E0 is equal to sigma by epsilon naught when there is no dielectric is present. Now when you place a dielectric inside it, then what will happen? All the negative charges will try to come towards the positive place, and all the positive charges will go towards the negative place. So what will happen here? These positive charges and these negative charges will create an electric field among themselves, and it is opposite to the direction of applied electric field. Enough. Is it clear? So here what we can say is plus sigma p and minus sigma p are the what? Are the it will be plus and it should be minus. So if plus sigma p and minus sigma p are the charge density, surface charge density at this point, then what we can write E suffix p equal to how much? Sigma p by epsilon naught. Now one thing you see, this electric field is directed in this direction, and the electric field produced by the dielectric is opposite to the applied electric field. So net electric field is given by E is equal to E naught minus EP. That means sigma by epsilon naught minus sigma p by epsilon naught. So we can take common 1 by epsilon naught equal to sigma minus sigma p. This is about the what is that one? Polarization of dielectrics. Now one thing, what is dielectric constant? This is a very important topic. Lots of time it's coming in the examination. What do you know about dielectric constant? We have just come to know that when there is no dielectric is there in between the capacitor, the electric field is inert and the value is sigma by epsilon naught. Now when you place this dielectric, so non-polar molecule inside the capacitor, then what will happen? They will create a dipole moment among themselves, which is opposite to the direction of the applied electric field, which is opposite to the direction of applied electric field, this EP. They are opposite to the direction of applied electric field. What does it mean? It means as you were giving initially whatever the electric field you were giving, now it is reducing. Now it is reducing and it comes as E. Is it clear? And this is the reduced value of electric field when a dielectric is placed inside it. When a dielectric is placed inside it. So the ratio between the original electric field applied in between the two plates of the capacitor to the reduced value of electric field when a dielectric is placed is known as dielectric constant. Clear? What is dielectric constant? It is the ratio between the electric field when no dielectric is present in between the plates of the capacitor to the electric field, to the reduced value of electric field when a dielectric is placed in between the plates of the capacitor. This is about your what? Dielectric constant. Clear? Now we come to next topic is polarization density. What is the next topic? Topic is polarization density. How can you define it? You know, we have a capacitor. In between them, when a dielectric is placed, what will happen? They will attain a dielectric moment. They will attain a dipole moment. That dielectric against a dipole moment. And that dipole moment developed per unit volume. Dipole moment developed per unit volume in a dielectric when it is placed in electric field is known as polarization density. Is it clear? Dipole moment develops per unit volume when it is placed in electric field is known as what? Is known as polarization density. The dipole moment per unit volume. So if P is the induced dipole moment. If P is the induced dipole moment of each atom of the dipole, and if capital N is the total number of atoms per unit volume, then what we can say, polarization density is rho equal to N into P. Is it clear? We have said P is the induced dipole moment of each atom of the dielectrics. Is it clear? And capital N is the total number of atoms per unit volume. Then polarization density rho equal to N into P. If capital A equal to area of the plates of the capacitor, D equal to distance between the plates of the capacitor, then volume of the capacitor will be how much? A into D. Let us assume that these charges, the charges, induced charges by the dielectric when it is placed in electric fields are plus Qi and minus Qi. if plus Qi and minus Qi are the induced charges on the two sides of the dielectric, then total dipole moment of the dielectric is equal to Qi into D. Is it clear? Dipole moment is generally distance, product of the charge and the distance. If D is the distance between them, then what we can say? Qi into D. Is it clear? Qi into D is the dipole moment. Is it clear? We have come to know Qi into D is the dipole moment. Now, what is the formula for polarization density? We just noted polarization density is generally dipole moment per unit volume. So what is the dipole moment? Qi into D. And what is the volume of the capacitor? A into D. So this D will cancel out and we will get what? Qi by A. But we know that charge per unit area is known as charge density, surface charge density. As it is charge is developed on the induced charge is developed, so it will be sigma into P for that dielectric. And we know on placing the dielectric slab between the plates of the capacitor, the reduced value of electric field, will be how much? E equal to E naught minus EP. So what we can say, sigma by epsilon naught is the value of E naught and sigma P by epsilon naught is the value of EP. So here do E naught minus P by epsilon naught. Is it there? So this is about your polarization density. Is it clear? So that is all for today.